How's it going, guys? Today we are going over another leak code question. Today our question is called Is Subsequence, and this is a question that's currently being asked by Google right now.
This is America. Don't catch you slipping up. Don't catch you slipping up. Look what I'm whipping up. This is America. Don't catch you slipping up.
Alright guys, today we're going over another leak code question. Our question today is called Is Subsequence, and this is a question, again, that's being asked by Google right now. Our problem description says, given a string S and a string T, check if S is a subsequence of T. You may assume that there's only lowercase English letters in both S and T. T is potentially a very large string, I guess, of length 500,000, and S is a very short string, less than or equal to 100 characters. A subsequence of a string is a new string which is formed from the original string by deleting some, which can be none, of the characters without disturbing the relative position of the remaining characters. So they give us, as an example, ACE is a subsequence of A, B, C, D, E, whereas AEC is not. And so let's just kind of digest that and think about that for a second. So ACE entirely appears, right? All those characters appear in A, B, C, D, E in the same relative order, right? A comes first, and then the next character would be C. C comes next in T, and then finally followed by E, right, which comes next. Whereas AEC is not a subsequence, and that's because they appear out of order, right? A appears first, which is great. Now we're looking for an E, which appears here, right? So that's the next thing, E, but then we don't have anything left. And so even though we have a C, it doesn't appear in the correct relative order. Therefore, AEC is not a subsequence of A, B, C, D, E. So now let's just go through example one. So we have S as A, B, C, we have T as A, H, B, G, D, C, and so we'd return true here, right? Because we're actually able to find all the characters in S in the string T in the same relative order that they appear in S, right? So we have an A first, which we find here, and then we have a B, which appears here, and then we have a C, which appears at the end. And again, those all appeared in the same relative order, therefore we'd say true, it is a subsequence of T. So now for example 2, if we have A, X, and C, and T is A, H, B, G, D, C, we'd return false, right? Because we have an A here, and then we never actually have an X, even though we have a C. So we'd return false. So hopefully that makes sense. If the logic doesn't totally make sense for what we're going to do, let's kind of talk through it now. But basically what we said we want to do is we want to find all the characters in S and see if they appear in T in the same relative order. And so what we could really do is we could have a pointer that points to a character in S, and we can iterate through T, right? So we're going to go through all of T, and basically we're going to say if the character that we have at our pointer in S is the same character that we're on in T, we can increment our pointer. So that means that we've effectively found whatever character that we're currently looking for in T. And if our pointer in S gets all the way to the end of S, that means that we've actually found all the letters in S successfully inside of T, so we just return true, it is a subsequence. However, if we actually iterate through all of T, and we've never found all the characters in S, meaning that our pointer never gets to the end of the length of S, right? Then we'd return false because we've actually exhausted all the characters in T and we've never found all the characters. So let's start writing that code. And first we're just going to do a little bit of error checking. So if we had a character, or I should say a string that's an empty string, right? If S was an empty string is by default a substring, or a subsequence, I should say, of T, because there's nothing to actually find. So we just say if S dot equals the empty string, we just return true right away. Awesome. And so now let's actually go through that logic that we talked about. So the first thing we want is a pointer, and again, that's going to indicate what character that we're currently looking for in S. So we're just going to say int index equals 0, and again, it's going to start at 0 because we're looking for the first or the 0th character in S to begin with. And now we want to actually start searching for that character in T, so we're going to iterate through all of the characters in T. So we're going to say for int I equals 0, while I is less than T dot length, I plus plus. And now we just want to check if those two characters are equal, right? So that means if t.char at I, so if the current character we're on is equal to s.char at our index, if those two characters are equal, then we know that we can start looking for the next relative character in S, which would just be at the next index. So we'll increment index by 1. And then if we actually, inside of this loop, if we ever get to the point where our index is the length or greater than the length somehow of S, we don't have to keep traversing through T, right? T could be 500,000 characters, they told us. If we found all the characters in S, let's just stop. So if index is equal to S, or I'll just say, just to be safe, greater than or equal to S.length, we'll just return true right away, so we don't actually continue traversing T because there's no point. And finally, if we actually get through all of S, all of T, and we've never found the last character or all the characters in S, we would just return false, right? So now let's quickly talk about our runtime here. So our runtime is going to be basically O of n, I'd say, where really n is just the larger of the two strings between S and T. So it'd be the maximum of whatever S and T's lengths are. In terms of the space complexity, I would also just say that I'd probably say that it's actually constant. It'd be O of 1, right? Because we're only using a single pointer here, a single variable, so we're not really using extra space. So I'd say our runtime is O of n, where n is the maximum of the two lengths of S and T, and I would say that our space is actually constant here, which would be O of 1. So let's run this, let's make sure that it works. Awesome, and it does. So guys, that's how to solve is subsequence in Java. Again, it's a question that's being asked by Google right now. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more. And I'll see you guys next time.
Ooh, yeah. On my Kodak. Black. Ooh, know that. Yeah. Ooh, get it. Get it. Ooh, get it. 100 bands, 100 bands, 100 bands. Contraband, 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 contraband. I got the plug on who a hawker. Whoa. They're gonna find you like fucker. Flow. America. I just checked my phone and listen. You motherfuckers owe me.